Hello everyone, myself Dr. Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's presentation on correlation part 2. Let us recall the previous session. In the last session, the introduction to correlation, types of correlations, quotient of correlation and methods to find quotient of correlation are discussed, and also the Karl Pearson's quotient of correlation. So how to find the quotient of correlation using Karl Pearson's formula. These topics were discussed, and also we have solved one problem on Karl Pearson's quotient of correlation. Here the correlation, it is a statistical analysis which measures the magnitude of the relation between two variables. For example, there are two variables x and y. Let us suppose x the independent variable and y the dependent variable. Then in general we write y equal to f of x. So in fact this gives the relation between x and y. And here using correlation we don't find what is the exact relation between the two variables in the form of an equation. We don't find that. Here we calculate how strongly the two variables are related. That means we find the magnitude of the relation between the two variables by finding the correlation quotient. So that correlation quotient is denoted by small r. And there are many methods to find quotient of correlation. One of those methods is graphical method. Graphical method. And also the mathematical method. Using a mathematical formula, we find the value of r. So by finding the value of r, we can study about the relation between the two variables. We can conclude that the two variables are strongly related or weakly related or no relation, etc. And this r lies between -1 and +1. So the properties of r lies between -1 and +1. So it can be -1 or +1. It can be 1, -1 or 0. If r equal to 1, the relation is said to be perfect and positive. If r is -1, again the relation is perfect and negative. If r is 0, there is no relation between the two variables. That means if you consider two independent variables s comma u, if these two are independent, there will not be any relation between these two variables. They doesn't depend on each other. So here in correlation we find the magnitude of the relation between the two variables. One of those methods is the Karl Pearson's quotient of correlation. So by finding this quotient, we can study the relation between the two variables. And this is given by small r is sigma capital X into y by under root sigma x square into y square, where now what is this capital X and capital Y? First, the data about the two variables will be given, x values and corresponding y values. X values and corresponding y values. Now, capital X is small x minus x bar. Capital Y is small y minus y bar, where x bar is the mean of x values, so sigma x by n. Y bar is the mean of y values, sigma y by n. So first we need to calculate x bar and y bar, then go to this formula. And we apply this Karl Pearson's quotient of correlation if x bar and y bar are integers. These two are integer values, then we can use this formula. These points were discussed in the last session. Coming to today's presentation, in today's presentation also I am going to continue the same. That means we find the value of r using Karl Pearson's coefficient of correlation. So let us solve some more problems on the same. The first one, calculate the correlation coefficient between age of cars and annual maintenance cost. Calculate the correlation coefficient between age of cars and annual maintenance cost. Also comment on the result. Now here the data is given. So let us denote the age of car by X and annual maintenance by Y. Here let us use the small notation, small x and small y. Small x denotes the age of car, small y denotes the annual maintenance cost. So the first row is corresponding to X, second row corresponding to Y values. Now to find the correlation coefficient, first how many values are given? 1, 2, 3, 4, 5, 6, 7 values are given. So total number of values given, n equal to 7. And first let us find the mean of x values denoted by x bar, sigma x by n. X bar is given by sigma x by n. That means add all the values of x divided by total number of values. So 2 plus 4 plus 6 plus 7, 8, 10, 12 divided by 7. So this is 6, 12, 19, 27, 37, 49 divided by 7. That implies x bar is 7. Similarly, calculate y bar. So sigma y values divided by n. That means 1600 plus 1500 plus so on plus 2000 divided by 7. So y bar equal to 1800. So it is very clear that x bar and y bar both are integer values. So therefore we can use the formula r equal to sigma capital Xy by under root sigma x square into sigma y square. So to find these values, the numerator and denominator values, let us construct the following table. The age of cars, small x values, and then capital X, then x square, small y values, capital Y, then y square values, and then xy values. Now what is x bar? X bar is 7 and y bar is 1800. So this capital X is x minus 7. Capital Y is y minus y bar is 1800 divided by 100. I am taking this divided by 100 just for our convenience. Otherwise, we will get larger values. So if we divide with 100, we will get simple numbers. As that 100 will be numerator and denominator, the simplification doesn't give any difference. So capital X is x minus x bar. 2 minus 7 minus 5 minus 3 minus 1 0 1 3 5. And we don't need this sigma capital X. So don't calculate, don't add these capital X values. We want x square values. So x square 25 9 1 0 1 9 25. Let us add these values. 25 plus 25 50, 9 plus 1 10 plus 10 70. So sigma x square is 70. Similarly, y values, we have y values and calculate capital Y values. 1600 minus 1800, which is minus 200 divided by 100, so minus 2. That means the calculation will be simple further. So that's why I am dividing this value by 100. 15 minus 18, so minus 300 divided by 100, minus 3, 0. 19 minus 8, 18, so 100. 17 minus 1, 21 minus 18, 3, this is 2. Now square the values of y, 4, 9, 0, 1, 1, 9, 4. So 9 plus 1, 10, 20, 28. This is sigma y square. Similarly, calculate x into y, capital X into capital Y. Forget about small x and small y. We have converted small x and small y values to capital X and capital Y. So capital X into capital Y, minus 5 into minus 10, minus 2, which is 10, minus 3, 9, minus 1, 0, 0, 1 into minus 1, 3 into 3, 5 into 2, so 20, 38 minus 1, 37, this is sigma x into y. And using the Karl Pearson's coefficient of correlation, R is sigma capital X into capital Y by square root of sigma x square into sigma y square. Let us substitute these values. Sigma capital XY is 37 by under root 70 into 28, which results as 0.836. So, the R value is 0.836, which is near to the positive value, near to 1. That means the R value is near to 1. That means there is a high degree of the positive correlation between the two variables. That we can conclude using this value of R. Similarly, let us consider one more problem. Psychological tests of intelligence and of engineering ability were applied to 10 students. So, the data is given about 10 students. And let us denote the intelligence ratio by IR and engineering ratio by ER. So, the values are given. Calculate the coefficient of correlation. So, IR and ER. I will denote the first one by X, second one by Y. So, total number of values n equal to 10. The data is about 10 students. Now, x bar is sigma x by n. So, 105 plus 104 plus so on plus 92 by 10. So, which is 99. Similarly, y bar is sigma y by n, 101 plus 103 plus so on 94 divided by 10, which results as 98. So, again x bar is 99, y bar is 98, both the values are integers. Therefore, we can use the formula sigma capital XY by under root sigma x square into sigma y square. So, let us construct the table, and here x bar is 99 and y bar is 98. So, 105 minus 98, 6, 4, 104 minus 99, 5, 3, 2, 1, 0, minus 1, minus 3, minus 6, minus 7. Let us square these values. 36, 25, 9, 4, 1, 0, 9, 36, 49, and add all these values, which gives sigma x square, sigma capital X square. Similarly, y values, and y minus 98, 101 minus 98, minus this is 101 minus 98 is 3, 103 minus 98, 5, 2, 0, minus 3, minus 2, again 104, 6, 92 minus 98, minus 6, 7 minus 98, minus 1, 94 minus 98, minus 4. Now square the values, 25, 4, 0, 9, 4, 36, 36, 1, 16, and the total sigma y square is 140 here. And also we need to calculate capital X into capital Y. So, this 6 into 3, 18, then 5 into 5, 25, 3 into 2, 0, minus 3, 0, minus 6, 18, plus 6, 28. And the total sigma capital XY is 92. And using the Karl Pearson's coefficient of correlation, sigma capital XY by under root sigma x square into sigma y square, we can use this formula when the means are integers. So 99 and 98, these are not fractions. So therefore we can use this formula, and substituting the values 92 by root 170 into 140, which results as 0.59. So like this, using the Carl Pearson's coefficient of correlation, we can measure the magnitude of the relation between the two variables. Today we have solved two problems on Carl Pearson's coefficient of correlation when the means x bar and y bar are integers. And what is the formula? Sigma capital Xy by root x square into root y square. So in the next session, again we use the Carl Pearson's coefficient of correlation, but a different formula when x bar and y bar are not integers. For example, if x bar is 19.6, y bar is 23.2, then we cannot use this formula. So we consider a different formula to find the coefficient of correlation. We will meet in the next session. Thank you very much.